So centripetal acceleration is the kind of acceleration you get because an object is moving in a circle. If you think about an object moving in a circle, even if it's at constant speed, it will still have acceleration because the direction of its velocity vector is changing. So in this picture here, we have a little cartoon of a car going around a circular racetrack. And let's say the speed of the car is constant. It's always going 30 miles an hour. But you can see that the direction of the velocity vector is changing, and because of the change in direction, we will have an acceleration. We know that the average acceleration of an object is its final velocity minus its initial velocity over the change in time. So this implies that the direction of the acceleration will be equal to the direction of the difference between the two velocity vectors. So let's consider these two velocity vectors that are taken a close time apart. And if we want to find the average acceleration, we would take the final velocity vector and subtract the initial velocity vector from it. So let's redraw our velocity vectors over here. So this is the final velocity vector. Then if we subtract the initial velocity vector, that means we take the negative, or flip the direction, and add it to the final velocity vector. So the sum of those becomes the acceleration, or actually the acceleration times the time interval. But this shows us the direction of the acceleration vector. And as you can see, the direction of the acceleration vector, and if we're doing an average, it should be taken from about here, is pointing towards the center of the circle. And in fact, that would be true no matter where you are on the circular racetrack. At every point on the circular racetrack, since the velocity vector is changing direction, there is an acceleration, and that acceleration points towards the center of the circle. So we typically write the centripetal acceleration with a subscript a sub c, and that centripetal acceleration always points towards the center of the circle. And it always has the same magnitude, or the same equation for calculating its magnitude. So the direction of the centripetal acceleration is towards the center of rotation, and it has a magnitude of the speed squared divided by r, where r is the radius of the circle that the object is traveling around. So that means if you have an object that is going in a circle, there are two possible kinds of acceleration. If the object is moving, you're going to have centripetal acceleration from moving in a circle, and that is due to the change in direction of the velocity vector. And then you can also have tangential acceleration, which is tangent to the circular path, and the tangential acceleration is responsible for speeding up the object or slowing it down. So if the rotation is speeding up or slowing down, if there's a change in speed, then there will be a tangential acceleration. If there is motion in a circle, there will always be a centripetal acceleration. Then if you need to find the total or net acceleration, since these two vectors are always perpendicular to each other, you can use the Pythagorean theorem in order to find the vector sum, or the magnitude of that vector sum. So here is a question for you. Let's say there is an object which is moving in a circular path with a constant speed. Which of the following is true concerning this object? Is its velocity constant, but its acceleration changing? Is its acceleration constant, but velocity changing? Are both the acceleration and velocity changing, or are they constant?